Hello everyone, I'm gonna talk about heat transfer in combustion engine. It's a very complex topic, but I will try to tell easily this topic. We will investigate three topics, and these are modes of heat transfer, piston heat transfer, and cylinder heat transfer. Firstly, I will talk about the importance point of heat transfer. There is a need to keep the temperature of two critical regions below material design limit. These regions are the piston, crown and exhaust valve. I will talk about modes of heat transfer. There are three modes of heat transfer. As you know, conduction, convection, and radiation. Conduction heat transfer formula is actually it is coming Fourier's equation. Q divided A is equal minus K to dt over dx. The figure below shows conduction torque piston cylinder wall. Convection heat transfer. Convection heat transfer formula is Q divided A is equal H brackets T1 minus T2. The figure below shows convection torque piston cylinder wall. Radiation heat transfer. Radiation heat transfer formula is Q divided A is equal epsilon to sigma to T over 4. The figure below shows radiation torque piston cylinder wall. Now I will talk about heat transfer resistance modeling. The conduction and convection heat transfer in engines are processes that occur in series and parallel with each other. A series path is convection throughout the cylinder gas boundary layer, convection across the cylinder wall, and convection throughout the coolant liquid boundary layer. And a parallel path is conduction throughout the cylinder wall and throughout the piston crown. Now I will talk about heat transfer to coolant. There are two types of coolants used to remove the heat from the engine block and head, air and water. With air as a coolant, the heat is removed through the use of fins attached to the cylinder wall. With water as a coolant, the heat is removed through the use of fluid-filled internal cooling passengers. Uh, as you can see in the picture, the figure below shows three resistors network for piston cylinder wall. I will continue heat transfer to coolant. The figure below shows cooling system loop. The water cooling system is usually a single loop where a water pump sends coolant to the engine block and then to the head. The coolant will then flow to a radiator or heat exchanger and back to the pump. And then piston heat transfer. The piston crown conducts heat from the conduction gases to the cooling oil to the piston rings and the piston skirt. Frictional heating is also a source of heat. The heat transfer coefficient depends on the engine geometric parameters such as the exposed cylinder area and bore and piston speed. Now I will talk about piston heat transfer, some formula. For the overall average heat transfer from the gas to the cylinder coolant convection type heat transfer equation are used. Q divided A is equal H T gas minus T coolant. The coefficient varies with location and piston position. The coefficient is found from a nozzle Reynolds number correlation. Cylinder heat transfer. The heat transfer from the hot combustion gases includes forced convection throughout the hot gas boundary layer, conduction throughout the cylinder wall, and forced convection into the fluid coolant in the head, engine block, and piston. There is a small radiative component of heat transfer from the gas to cylinder walls. Uh, the heat transfer process is periodic due to piston motion. However, the engine speed is usually high enough so that the temperature fluctuations only penetrate about a millimeter into the cylinder wall. The penetration depth of temperature fluctuations into the cylinder valve is calculated as below. I put some formula for you. Finally, cylinder heat flux. The figure below is a representative graph of the cylinder heat flux as a function of crank engine. The heat flux begins rising when the combustion flame impacts the cylinder wall, has a maximum at a peak cylinder pressure when gas temperature peak, typically 20 degrees after top dead center.